In this problem, we're going to use the work kinetic energy theorem to find the height or the speed at a height that is not at its maximum height in a rocket launch. In this rocket launch, we have a mass of our rocket of 150,000 kilograms. And it's launched straight up. So we have some rocket. It's going to be launched straight up. The rocket motor generates a thrust. So some force of the engine is equal to 4.0 times 10 to the 6 newtons of force. What is the rocket speed when we get to a point where it's up here, still moving, a height of 500 meters? And we want to find its velocity. And we're going to ignore air resistance. So we're going to use our work equation. If the force is constant, is equal to the force times the change in distance. So this is equal to 4.0 times 10 to the 6 newtons times our height change, which is 500 meters. So this is 2.00 times 10 to the 9 joules. So our work done by our force is 2 times 10 to the 9 joules. This is the work done by the engine. There is another force acting, and that's gravity, since we're in the y direction. So we need to calculate the work done by gravity as well. It has a negative mg, because it points downward compared to the thrust of the engine, times delta S. This is negative 1.5 times 10 to the 5 times 9.8 times 500. This is negative 0.74 times 10 to the 9 joules. So this is the work done by the gravitational force. Remember, you have to do every single force in the problem. So it's not just the engine, it's also gravity. So now we need to find the total work. The net work is equal to the work done by the engine plus the work done by gravity. And that is equal to 2 times 10 to the 9 minus 0.74 times 10 to the 9, which is 1.26 times 10 to the 9 joules. So our net work is equal to the change in the kinetic energy. The change in the kinetic energy is 1/2 mv final squared minus 1/2 mv initial squared. This rocket starts from rest, so our initial velocity is 0. So our net work is 1.26 times 10 to the 9 joules. That is only equal to 1/2 m. Well, let's plug that in. M was 1.5 times 10 to the 5, v final squared. Which means that v final squared is equal to 2 times 1.26 times 10 to the 9 divided by 1.5 times 10 to the 5. So Vf is equal to the square root of 2 times 1.26 times 10 to the 9 divided by 1.5 times 10 to the 5. Which means our velocity is 130 meters per second.